All right, so we're going to talk about proofs with coordinates. So for these first 6, these are the ones that we're going to work on together. We're going to work on together. So let me write them up. You might want to write them in your notes, and then we'll go over the answers so you can write your answers down. What the question is, can we use coordinates and if so, how? So I have 6 things, six questions. And each of these is separate, so they're not about the same thing. All right, so there are six things that we're trying to figure out. Is segment AB parallel to segment CD? These are all separate. They're not the same thing. Does segment AB bisect segment CD? Is angle A congruent to angle B? Is the length of segment AB plus the length of segment BC equal to the length of segment AC? Is this shape a rhombus? Are these two angles supplementary? We want to know, can we use coordinates to figure these things out? And if we can, how do we do it? So we don't have to figure it out. We would just say, here's what we would do to figure it out. So with your partner, table partner, one of you grab an opener slip, answer these 4 questions, or these 6 questions, and then in a minute we will go over them. So for number 1, we want to figure out if these 2 segments are parallel. Can we use coordinates to do that, Jordan?
Yeah.
Yes. That's one thing that coordinates are really good for. What would we use? Slope. So we use slope. And what about the slopes would tell us that these are parallel? They're the same, right? Slopes are equal. How about number 2? If we want to find if one segment bisects another segment, can we use coordinates for that, Danny?
Why are you asking me?
Your name came up on my little cards.
No, I don't think so.
No? What does bisect have to do with?
Cuts it in half.
Cuts it in half.
Yeah.
Do we have something with our coordinates that lets us find the middle of something?
Yes.
Yes, the
Midpoint
formula. So that would be yes.
I think so. I just don't mind it.
Oh, I need one of those.
All right. How about number 3? We are looking for angles. We want to figure out if these angles are congruent. Can we? All right. Can we figure out if angles are congruent with coordinates, Tor? Tor says no. Okay, so we what do you say, Keone? So what we're talking about, we can think about this a little more because this one does. There are some special circumstances here. So we know the endpoints of some segments like that, and some endpoints of some segments like this, two segments like this, and we want to figure out if they are congruent. So the distance formula would tell us if these two sides were the same, but that wouldn't really tell us about the angles. When might we be able to use coordinates to find out about angles? All right, very good. Guys, so what Carolyn says is if both of these angles are 90 degrees, how would we use slope, or, whoops, give it away. How would we use coordinates to figure that out? Slope, we find the slopes. So if they were both 90 degrees, so I'm going to say no, unless $90 degrees. Now when you go further in math, you will learn ways to figure out the angles between those two segments, and it has to do with what I was talking about that's on my shirt with vectors. It's kind of nice. All right, number 4.
Do you play on that?
So they play on it? I played it for what we were talking about in my other class. We were talking about normal normal vectors in my other class.
Coordinating your outfits with you.
Sometimes.
With what you're teaching.
Sometimes.
That's pretty cool.
All right, so number 4 says AB, the length of AB plus the length of BC is the length of AC. Can we use coordinates to figure that out? What do you think, Anna? Number 4? Yes, with the distance formula. This is asking us about lengths.
That's not another one. Of course you guys are getting it.
Anytime we're looking at something that has to do with lengths, we can use the distance formula. All right, number 5, we're trying to see if this shape, ABCD, is a rhombus.
Yes.
Can we figure out if the shape is a rhombus, Mackenzie? All right, folks. Let's stop talking, please. All right, so what is it, Mackenzie? All right, very good. So Mackenzie says yes, and we would use the slope formula to decide what? If the sides are parallel, yes. And the distance?
I said I don't know.
And we use the distance formula to do what about this thing?
I said yes.
To find if the side lengths are the same. Slope and distance. Because we need it to be a parallelogram and we need the sides to be the same. All right, finally, number 6. These two angles A and B are supplementary. Tanner, can we decide if these two angles are supplementary? No. But let's think about number 3.
Unless we don't have
Unless we can figure out they're both 90 degrees. So in general, no. And I'm going to say unless they're 90 degrees. If they're both 90 degrees, then we could say they're supplementary. But that's really a special case. All right. So most of your homework looks like this. These kinds of ideas. Can you use coordinates to figure them out? If so, how would you do it? But there is one proof. The first problem is a proof. So what I want to do is go through a similar proof using coordinates. All right, so here's the setup. All right, guys. Let's stop talking, please, so we can get finished with this. All right, so we have this triangle. And the coordinates of that point are negative 2x, 0.
Yes, yes.
The coordinates?
No, yes.
All right, guys. Stop talking. Coordinates of R are positive 2x, comma 0. And the coordinates of Q are 0, 2b. And we're given that we have triangle PQR. And this is an isosceles triangle. So PQ is congruent to QR. And we want to prove that the medians to PQ and QR are congruent. So here's our setup. First thing we need to do is remember what a median is. Do you remember how we find a median in a triangle? That's the midpoint. That's a midpoint. It has. We're going to use. So you're a little ahead of us. Mm-hmm. Very good. From a vertex to the middle of opposite side. So let's draw in the medians. So this is what you were thinking, Porter. I'm going to call that point N. That's the middle of that side, and that point M. That's the middle of that side. And my median is going to go like so. All right. So we want to prove that. What we're trying. If I rewrite this, we're trying to prove that MR is congruent to NP. So we're trying to prove that these two segments are congruent. So what are we going to use if we're using coordinates? What are we going to use to do this? Distance. We're talking about the lengths. But we have one step in between. We have the lengths of these that go from the midpoint of these two sides to the vertex. So what do we need to find the lengths? We need the coordinates of those midpoints. Can we find the coordinates of the midpoints using coordinates? Use the midpoint formula, right? So we need to find midpoints, and then we need to find distances. So let's do the midpoints over here. I knew what you meant. So we're going to find the midpoint for M. So the midpoint, this is between P and Q. So let's write our points. The points are negative 2x and 0, and Q is 0, 2b. And label our points, x1, y1, x2, y2. So M, x1 plus x2, negative 2x plus 0 over 2, and y1 plus y2, 0 plus 2b over 2. And negative 2x plus 0 is negative 2x, and negative 2x divided by 2 is what? Negative x. And 0 plus 2b is 2b, and 2b divided by 2 is b. Very good. So there's one midpoint. Now let's find the midpoint between Q and R. So our points there are 0, 2b, and 2x, 0. So we'll label those x1, y1, x2, y2. So n equals the point x1 plus x2, 0 plus 2x, divided by 2, and the y1 plus y2, 2b plus 0, divided by 2. So n equals 0 plus 2x is 2x, divided by 2 is x. 2b plus 0 is 2b, divided by 2 is b. So there are midpoints. Now we need to find the length of MR and NP. So we found our midpoints. Now let's find lengths. MR. So point M is negative xb, and point R is 2x, 0. Label our points, x1, y1, x2, y2, and we're going to find our distance, our length there. x2 minus x1, 2x minus negative x, squared, plus y2 minus y1, 0 minus b, squared. What's 2x minus negative x? 3x. So I have the square root of 3x squared and negative b squared plus b squared. Negative b times negative b is b squared. All right, so there's the length of MR. Now we're almost done. The length of NP. So the point N is xb, and point P is negative 2x0. Label those x1, y1, x2, y2, and we're going to calculate our length there. We're trying to show that they're the same. So x2 minus x1, negative 2x minus x squared, and y2 minus y1 plus 0 minus b squared. Negative 2x minus x is negative 3x squared, and negative b squared we decided was plus b squared. Well, 3x squared, if I square 3x, what do I get? 9x squared plus b squared. And this equals, if I square negative 3x, what do I get? Positive 9x squared plus b squared. Are those two the same? Yes. Those two lengths are the same. So MR, is it MR? Is congruent to NP. And that's what we were trying to prove. These two are the same. Using coordinates is a little on the tedious side. I will agree with that. But it's a very powerful tool. But there's only one of these on the homework. The others are like the ones we did before. All right, questions? All right, homework. There we go.